Alright, so this is the walkthrough of my spreadsheet for my exploration project. Um, just some initial notes here. Here's the setup for my problem. So the total number of items per year, storage cost per item, flat storage fee, reorder cost per item, and reorder fee were all values that you should be able to edit. And the goal of the problem was then if you could, whatever values you put in for those, it should spit out the lot size that minimizes the inventory cost and the number of reorders per year for that specific lot size that you find. So the first step I did was I made a total storage cost and total reorder cost, which I was able to do based on some of the knowledge I had from tutoring. I tutored some individuals on how to uh, write cost functions with given information, and I've used information similar to this. So this is the so that's like the information I used to get started on this problem, and that's why this problem interested me. So the total storage cost would be cell C4 times C13, which is the lot size, over 2 plus C5, and then the total reorder cost would be C8 times C13, the lot size, plus C9, times C2 over C13, which will also, as you'll see later, end up being the number of reorders per year. C13 is actually my x value, quote unquote, when we're talking about this in an algebraic sense, because the cost function depends on x, and x is the lot size. So I just added those together and replaced C13 with x to get a cost function over here. And then I created an f of x plus h function because my first thought process was to find a critical point because I was minimizing, so I thought I had to find a minimum, so I needed to find where the derivative equals 0. To do that, I thought about, because I couldn't find any specific derivative command in Excel, I thought about taking derivative as a limit, so I created my first table to see if it would work, a mini table. So this one goes from 100 to 0 by 10, and then the h value up here goes into all of these, this whole column, and it's just I just chose a really small value for h because I knew it was approaching 0. And then I had f of x, which is just this function up here with this x value plugged into the left, and then f of x plus h is the same thing. It's this function up here with f of x plus h, and with h and x plugged into this f of x plus h function. And then these values are calculated as you see up here, f of x plus h minus f of x over h. And this did work. It did end up giving me a rough limit, you would say. And so I noticed that where it goes from positive to negative must be where the critical point lies. Unfortunately, in this one, it's between 60 and 50, the critical point. So to make it more precise, I went by 1 instead in another table. So it goes from 1 all the way to 0. And I was able to pinpoint it down to a range of about 1. So as you can see, between 59 and 60 is more of a precise location where the critical point is. This is created in the same setup as the table by 10 was. And then my issue was trying to find a way to select the two values around the critical point, so I could test both of them and see which one gave me the true minimum cost. I tried doing this thing where I said if the limit is positive, it says no, and if it's negative, it says yes. And then because it is, and I was trying to say, okay, well, if two values have different words, so if one says no and one says yes, then I wanted to say critical point next to it. However, the issue was the code I created for critical point, not critical point, only worked one way, so I was testing the values going down. So for example, this one and this one I was testing against each other, so and because of the same, it said not critical point. I was testing this one and this one against each other, so they're different, so it says critical point. But then for 59, the other value I wanted to find, I wanted to select, I was testing it against the one below it, and because of that, they're equal, they're both the same words, so it said not critical point instead. I tried going the opposite way, but that just ended up switching these, so this one had critical point next to it, but this one had not critical point next to it, so I was having issues trying to properly select the critical point. The 2 points that were quote-unquote critical points where I could plug them in and see which one gave me the minimum value. I also didn't know if maybe there was another critical point at 1,000 or maybe like 500, and I would have to create this table for a lot more values. I ended up finding out later using the GeoGebra that there is only one critical point that I have to deal with, but I didn't know that, so it seemed really inefficient. So I tried to move on to a second attempt, and after observing GeoGebra, I found out that I could rewrite I could rewrite the x value, the critical point, as an expression. So I copy and pasted the initial setup over here into the second spreadsheet, and then here is the total cost function. Here is the total cost function. Once we were able to find C13, I just made it so you can see the total cost for the year. using the exact lot size. So this is the derivative function, which it's written in terms of the cell values, but it's also represented algebraically because I solved for that in my work that I put in my reflection. And the x value of critical point, which I found algebraically, is the square root of 2 times C9 times C2, so 2 times the flat reorder fee times times the total number of items per year, all over C4, which is this total storage cost per item. So the square root of 2 times C9 times C2 over 4, which is also in the algebra that I posted into my reflection. And then, just like before, I knew that I needed to test the values around the critical point, so I rounded it up and down around the critical point and tested both of those values. So I tested the cost function. So this is the cost function, but with the rounded up value plugged in from here. And this is the cost function with the rounded down value plugged in from here. And I created this best number of items section where I said if P13, so if this one's less than this one, then we want to select the value that gave me this one, which would be the one rounded up. But then if this one is greater than this, then we want to select 59 because it is the lower value. So basically this just selects whatever the lower cost function is, it gives me the corresponding rounded value. And so then great, I had the lot size, and minimized inventory cost. The issue I then ran into was about reorders and then organizing the reorders and the remainders. So I knew that if I have a total number of items per year and there's going to be this many in the lot size, which means this many in each order, then the number of reorders over here was the total number of items per year, so this divided by the lot size. This was off to the decimal. Originally in here, I had just to say round. It didn't say round down, it just said round this value to obviously 0 decimals. So I could get a whole number of reorders. And when I had it as just round, I was consistently getting negative remainders sometimes, which I knew I couldn't use. I couldn't split up negative remainders among the orders. So I was trying to figure out how to solve that. So here's where I tried to solve it. I tried to this is the function for the remainder, so it's the total number of items times C13 times C2. So this gave me the actual remainder. And then I tried to say if the remainder was negative, then I would say yes, and if not, it would say no. And then if it was negative, I wanted to round it down. But then I realized I could just round it down here. So the function I had here, I put here. I also had to put it in the round down here because when I tried to do that here, I kept getting a circular reasoning issue because I was trying to observe the remainder, and then by observing this remainder, I was trying to change the value that was here. But in order to get this remainder, I had to use the value that was here. So there's a bunch of circular reasoning issues because I couldn't simultaneously use this to change this value if this value was created from C12. C12 was one of the things that created the remainder. So I just rounded this down. I realized that was a pretty simple solution. I rounded down. So I would always have a positive remainder. And then my issue, which is kind of where I got stuck and kind of the thing I'm still exploring, is how to split up the remainders. Originally, I just wanted to find the difference between the number of orders and remainders, and then put a remaining item in one remaining item per order, or as many orders as I could put a remaining item in. So for example, in this situation, I would say there's 42 minus 22, so there's the difference is 20 orders, and so then I would say the order, I was trying to figure out, so if I would have 22 orders with remainders, then I would have to have 20 orders without remainders, but then the issue was I need to make sure the average of those orders, the lot size, was 59, and I was having an issue creating that. I didn't necessarily know how to make sure the lot size was consistent while also splitting up the orders. Here I tried calculating the items in non-remainder shipments, but if I'm being honest, I am still confused about why I did it this way. So yeah, this is like, I'm still kind of exploring this, and that's kind of where I would be looking at right now. So yeah.